What they're a load test, which is what we're going to do show you with this. A load test basically is how many amps will my battery put out. Will my battery, when it's under load, produce enough amps to start my vehicle? And so a load test, in an indirect way, yes, it's testing this, but no. It's actually testing the capacity of your battery to see if it will work or not. The only way it will work is if this is actually taking place. So that's why it's indirect. It is taking place, but that's not exactly what you're testing for. If your battery becomes partially sulfated, and part of these plates have a hard surface on them of sulfate, when I do a load test like you asked about, since there's no chemical reaction, it will not give off any amps, and it will be bad. And then we're going to talk about how we can unsulfate our battery and how you deal with that situation. So during a discharge, the lead plate, the lead sponge changes into lead sulfate. The positive plate, which is lead peroxide, changes into lead sulfate too. They both become lead sulfate and become sulfated. The electrolyte solution, the sulfate of acid unites with the active plates, leaving a weaker acid solution. Basically, it's mostly water. The other problem that you're going to see is you have oxygen molecules breaking free, and you have hydrogen molecules breaking free, and they're in solution. And they're going to float around until they can actually run into each other and bond. Well, some of those molecules are not. They're going to be floating around, not run into another molecule. Where are they going to go? If I have hydrogen and I put it on the floor here, what will it do? Hydrogen rises, doesn't it? Really quickly. And so when you have this activity taking place, there's hydrogen that's allowed to break free out of the solution, and it rises. And if I take a match and put it to hydrogen, what's it do? It's one of the most explosive bombs that are out there. Hydrogen bombs, you know, they're pretty powerful. And so why is it so important that you need to be cautious about how you jumpstart a battery? It's because when this reaction is taking place, hydrogen and oxygen molecules are both being free. And some of the hydrogen, if it cannot run into an oxygen molecule, by the time it reaches the top of this battery, will go out the vent. And you're going to get hydrogen pooling around the top of this battery. And when you go to hook your battery cables up, you create a spark. You've got hydrogen, you've got oxygen, you've got electricity or spark, and the battery will blow up. And there is a lot of batteries that blow up every year because of incorrectly hooking up jumper cables. And so you need to be very cautious. When this battery blows up, it sprays sulfuric acid everywhere. It's going to get in your face, it's going to get in your clothes, the whole engine compartment, everything. And so you can get severely burned, mainly because of the acid. I mean, there's going to be an explosion that's going to damage you. There's particles flying in you. But the thing that damages people the most is actually the sulfuric acid. If it gets in your eyes, it's going to burn your eyes, it's going to burn your skin, your clothes will be pretty much toast, your paint job, your engine compartment is going to have, it's just an ugly picture. You're not going to care about it if your face is all out of there, but so you got this battery that's discharged. What happens when I put it on a battery charger or my alternator kicks in is it runs an electrical charge in reverse through these plates. And when it does that, it pushes the oxygen molecule that's in solution back onto the plate. So this now changes back into lead peroxide, and the other plate turns back into lead sponge. The SO4, this, which is actually attached out here, will push back into solution, attaches itself to the hydrogen. When it attaches to the hydrogen, there's going to be a period of time where the hydrogen molecule is again free until a SO4 can actually capture it. You got hydrogen gas starting to rise up. If you look in a battery, you'll see bubbles. Those bubbles are oxygen and hydrogen. And they're rising. You light a match, you're smoking a cigarette, you hook up your battery cables wrong, you can be hurt. And you can be severely hurt. So be very careful about what you do with batteries.